board. Just a minute. Right, adjust the board. Okay. That will be required later. Okay. Is the voice clear? Voice clear? Clear? Okay. I'll start now. See that couple question, some 2 extra questions I have to solve. One of them is, if I apply hogging couple, BM will come negative. Other thing is same. Load will become upward. And if I apply both side couples, symmetry will come. That I will take after this question, because if I start that one, it may take some half an hour. Then this question will be halfway through. So I will first go this one. Then next class, when I get little time, I will give that question. Okay, see. Now, important question, right heading. Simply supported beam with eccentric, concentrated or point load. Concentrated load. Now see, same thing in moment area. I told so many things. Draw a tangent here, take it there. Draw a tangent there, take it here. That all struggling is not there in conjugate beam method. That means in conjugate, if unsymmetry or eccentric load is there, amount of work is very, very lesser. Okay, start. Heading over. I will first give question. Procedure I will give simultaneously. As I solve, I will give procedure. You should write the procedure. 1 minute. Let me mark the boundary of the board up to where I can go. So that up to here, no problem. Little up to here, okay. Yes, up to here there is no problem. So, okay. Now full board I have got. Here also up to here. So that I should not. Okay, no problem. See. I will put questions. Two critical questions right here. 2 critical or master questions. Question number 1. I will write here. See, I will solve both the questions here. Then I will go that side. See. Question number 1. I will give words. A simply supported beam. See, same question we solved by moment area method. I can take the same question. I had to go to earlier YouTube class and then search it. No, do one thing. Those questions solved by this method, these questions solved by that method. You got extra benefit now. A simply supported beam of span, any span, say 8 meter, is loaded by a concentrated load of magnitude, anything will do, I will take multiple of 8 so that fraction will not come. 48 kilonewton at 3 meter from left hand. Okay, A, B and C. This is C is not center now. C is the load point. Now, question number 2. Question number 2. A simply supported beam of span 10 meter. Okay, 10 meter is loaded by a concentrated load of magnitude, say anything, on the 120 kilonewton at 4 meter from right end. So what is the purpose of the question? One question, load is this side. One question, load is that side. So that when the beam bends, first question, Y max will come that side. Second question, Y max will come this side. For that purpose I am doing. Once these two are over, you can solve any question. See, now, for both the questions, find one, theta max, then slope and deflection under the load. 1, theta max. 2, theta max means what? Slope at supports. Okay. Or I'll do one thing. I'll put theta at supports. How many times I have to tell? Theta at supports. Then theta and Y under load point. 3, maximum deflection. The maximum deflection is red color. What I will do is, that particular point I will locate using red color. Why? Important. Some location is there. Okay, leave it. It's a 3. Now, start both the questions. Put the sketches. Mark reaction here. VA and VB. Here also VA and VB. You solve first question, complete the first question, then start second question. Don't do simultaneously. Okay. Now, I should not tell me what VB will come, what VA will come, what VA will come here, what VB will come. Fast. This, see, take moment about A. Minus VB into 8 plus 48 into 3 equal to 0. VB will come. Sigma V0, VA will come. If this you are not able to calculate, then you are wasting time coming to my class. 3 divided by 8. VB will come 18 kilonewton. You have to calculate it. VA will come 30 kilonewton. First question. You have to separately show the calculation, not enter there. And second question, VB will come 72 kilonewton and VA will come 48 kilonewton. Tell me, both are correct? Both are correct? No, tell me, both are correct or not? Reactions. Both the reactions correct? Where is my mobile? Here. I think I don't have to ask. Both correct. Okay. Now, start. You do one thing, you write first question. Then, first to find reactions. Systematically solve. When everything is over, then start second question. Okay, now, I will start question 1 continued. See, question 1 continued. Little later, I will do second question. See, very neatly draw the real beam. Double line to show that it is a beam. Okay. There is a reaction here VA, reaction here VB. This is VA equal to 30 kilonewton, VB equal to how much? 18 kilonewton. Okay. Now, span is 8 meter. Load is somewhere here. See, I will put the load. Load is 48 kilonewton. Distance from here is 3 meter. Then remaining is 5 meter. 5 meter. Point A, point B, point C. Is the top of the board visible? Just tell me. Is the top of the board visible, or shall I slide the camera down? Visible, no? Everything visible? Top portion what I wrote, visible? No comment. Top portion, I think it is visible. Okay. Now, draw bending moment diagram. So this is bending moment diagram for, I will put real beam. So right here, this is the real beam. Don't write RB, real beam. Okay. For that, show the calculation. See, sagging positive. All values are in kilonewton meter. So side by side, show the calculation. I am rubbing this one. BM at A equal to 0. Look that side, equal to BM at B. Then next standard point is C. BM at C, see, equal to plus 30 into 3 equal to plus 90. Or if you look that side, plus 18 into 5, that also 90 over. So here, linear variation, 90 here and this way. This is the BMD positive. Okay, now second question, see, I will tell now only, you have to start it. When you draw BMD here, BM0, BM0, BM here, if you look this side, 48 into 6, or if you look that side, 72 into 4. So this second question, up to here, you can correctly do it now. I won't explain. When I finish first question, second question, up to here, there is no problem. Okay. But second question, this will be 6 meter, that will be 4 meter. Okay, now, draw BM by EI diagram. Be careful. 0, 0, here 90 is there. So instead of wasting time, same shape. This is 90 by EI. This is called BM by EI diagram. Okay, now, this BM by EI diagram, you take as a loading diagram on an imaginary beam. That imaginary beam is called conjugate beam. Put it down, blue color. Today blue color. This beam is conjugate beam. There's a reaction here called VB dash equal to later. There's a reaction here, all imagination, VA dash. Just to understand, mark distance here also. It is 3 meter and out of scale slightly, okay, 5 meter. Now, for the conjugate beam, this is the loading diagram. Whatever BM diagram you got for real beam, that will become loading diagram, but direction of load. If the BM is plus, I told load should be taken down. See, this way. Load should be taken down. Now, there is one triangle load here and one more triangle load that side. Okay, now, next step is, I write here, calculation of reactions for your conjugate beam. This reaction. Now, in earlier question solve, symmetry was there, so directly we should write VA dash equal to VB dash equal to total load, 1000 times I told, load equal to area divided by 2. This time you can't do it. Why? Unsymmetrical. Therefore, apply equilibrium condition. Take moment about A. I forgot to write A here. This is A, this is B, this is C in conjugate beam. Okay. Start. Sigma m about A equal to 0. 1 minute now. I will tell you your second question. See, when you do second question later, because I want to save the time. VA is 48 kilonewton. This will become 6 meter. Your BM by EI diagram will come like this way. How much it is? 48 into 6. I will write and walk out. 288. So when you draw BM by EI diagram, it will become this way. This is conjugate beam, this is 6, this is 4, reaction here. So once I finish the reaction there, for this also, you have to find the reaction. What all I do there, you should do here also. Y max I will do separately for both. Okay, now, take moment about A. See, it is a moment, not bending moment, clockwise positive, minus VB dash into 8. Minus VB dash into 8. Then plus, there is one triangle load here. See, one triangle load. Tell this load, half into 3 into 90 by EI is the total load into its center of gravity will be somewhere here. From moment about A you are taking. So from here to CG is 2/3 of 3. 2/3 of 3 plus once again this loading, half into 5 into 90 by EI is next one into its CG will be here. See, from moment about A, 3 meter outside plus another from here to here is 1/3 of 5 equal to 0. You get the value of VB dash. Correctly calculate and tell me VB dash value. Over. I finished the complete question. Okay, don't worry. I finished the complete question there. Okay, start. Answer. Full question over. 195. 195 OUV dash. Huh? I got 195 is V actually. VB dash 195. VB dash 165. See, because I got the theta B 165 here. See, you can't do this way. VB dash is plus 165 by EI. Okay. Now, sigma V equal to 0, take upward positive. What do you get? Plus VA dash plus VB dash minus this total load. See, when you take moment, this triangle separate, this triangle separate. Because this area into 2/3, that area into 3 plus 1/3. But when you want sigma V, you want total load, only area. When you want the only area, you don't have to separate it now. Single stretch you can do. What? Minus half into directly 8 into 90 by EI equal to 0. You know VB dash. Therefore, tell VA dash how much? VA dash. Directly you can do. Or if you are eager to do one thing, calculate. Half into 3 into 90, half into 5 into 90. VA dash. 208.75. VA dash will come 195 by EI, I think. What is 195? Correct. VA dash. Half into 8 into 90, subtract 165. See, you are giving contradictory answers. Anyway, I know my answer there. 195 by EI plus 195 by EI. Now tell me, second question up to here, can you do it? Tell me now. Second question up to here, which side is more distance is not considered. See, here right side is more distance. There, second question, left is more distance. That will not come for all this calculation. Which side is more distance comes only for y maximum. So till y maximum, both questions are identical. Therefore, as soon as I finish first question, I will write second question, and all these I will give direct answer. Agreed? Yes, okay. Those who are serious will do it. Okay, now, right here. Go back and enter. Enter the answer. Always remember, enter it. VB dash is 165 by EI. Rounded means calculated. VA dash is 195 by EI. Today we will finish both the questions. See, momentary, if you remember, we struggled 2 classes. Remember it? For this question, we took 2 classes. Today both will finish in 1 class only. Why? Easier. Now, I will remove this one. I do not want this calculation. Okay, start. Now, find whatever required. Start. First one. What do they want? 1. 1 they want slopes at supports. First, slopes at supports. That means they want theta A and theta B. Okay, start. First, theta A clockwise in real beam equal to shear force at A in conjugate beam left up right down positive equal to slope here is shear force here. Come slightly this side. Left up is positive plus 195. If anybody is not clear, leave my class. Don't come once again to my class. Therefore, answer theta A equal to 195 by EI radian clockwise. One answer came. See, I already wrote theta A for first question. Then, after theta A, theta B clockwise in real beam equal to shear force at B in conjugate beam. Left up is positive, right down is positive. See, shear slope here is shear force here. Come slightly inside. Look that side. Right side up is negative. Minus 165 by EI. Therefore, your theta B equal to 165 by EI radian anti-clockwise. This is also over. Now, those who want right here, those who want. Suppose in the question, if the question they ask, what is the maximum slope, you should write. Then we know that simply supported beam, maximum slope is either at left support or at right support. We got the 2 support slopes. Therefore, the maximum slope for this beam is 195 by EI. You write all the statement and write, therefore, theta max equal to 195 by EI radian for this question at the left support A. If they ask it, I am not telling it here. Okay, start. Over. Now, next what they want? Slope and deflection under the load. See, second one. Slope and deflection. Slope and deflection. Deflection under the load. Under load. That is at the point C. That is they want what? Theta C and YC. Start. First, theta C clockwise in real beam equal to shear force at C in conjugate beam. In conjugate beam, left up, right down, positive. Okay. Slope here is shear force here. Any side you can look. Look left side. Plus 195, only shear force. No into. Plus 195 by EI minus this much load. No into. This much load is half into 3 into 90 by EI. Tell the answer. Answer. It will come plus. Next question, it will come minus. So here, slope is clockwise. Next question, you write anti-clockwise. That is not a problem. Answer. Don't tell the answer I wrote there. Never do it. You should always check the answer. Plus 60 by EI. Plus 60 by EI. So present the answer. Therefore, slope at C equal to 60 by EI radian, positive came clockwise. Now, this reaction for conjugate beam space, I will remove, because why? This you have second question, you have to do it. Otherwise, don't come to my class. If you cannot solve identical question and still you want everything written, my class is not ideal. Okay, now see, deflection at C downwards in real beam equal to bending moment at C in conjugate beam sagging positive equal to deflection here is bending moment here. Look any side, look this side, plus 195 by EI into 3 minus moment of this load about C. So half into 3 into 90 by EI is the total load into moment about C. 1 by 3 of 3. Why I am not asking you? After this much number of classes, if confusion is there, not fit for education. Answer. I will harshly tell, not fit for education. Answer. Don't see the answer there I wrote. You calculate and tell me. You never worry how I wrote those. See, I wrote all the answer there. Some will tell, he already by-hearted before the class and wrote. You change the question if you want. Plus 450 by EI. It is plus 450 by EI. Therefore, deflection at C equal to 450 by EI meter down. That is the answer. Okay, now I will remove everything now because I want this full space to finish the first question. Second question, I will make a note. 120 load, this reaction is 72, this reaction is 48. 6 meter, 4 meter. Sufficient for me. Sufficient for me. Okay. I will remove the full board now because why? I want systematically to do Y maximum. Okay. Okay. Sufficient, huh? Sufficient. Okay. Now, lastly, most important, 3. Calculation of maximum deflection. Maximum deflection. See, if you remember, that is Y maximum. If you remember moment area method, how much you struggled. Okay, now start. First make a note. Our beam is like this. This I told you thousands of times earlier. The load is applied here. Therefore, this is A, this is B, this is C. The beam will naturally bend like this. Tell me, Y max will be to right of C or left of C. This I told so many times earlier. Go back to moment area method, go back to Macaulay's method, everywhere go back and say, right. Y max will be somewhere here. See, I use red color. Somewhere here is Y maximum at a point X. This is deflection at X. That is Y maximum. I will take X from this side. Very important. And where Y is maximum, slope theta at that point is 0. Okay, now statement. First write, Y max will be between, see, if you take X from A, you tell A and C. If you take X from B, you tell B and C will be between the points. Which points? B and C. Y means I told you, B and C. Reason told for you. Now, let Y max be at a point X, comma, at small x from where? See now, Correctly observe. A point somewhere here. See here. If I look left side, you can see a triangle and trapezium. But if you look right side, you can see only triangle. So better x from that side. So x from B, very important. YB, just now I told, or moment area method told thousands of times. Thousands means what? Repeatedly told. Okay, start. Now you also know that, now first to locate the point x, use the property. We know that at the point of y maximum, slope theta, that is theta x, equal to 0. So use this property right here. Use this property to locate x. You should write. So therefore now once again go back here. Mark without disturbing anything. Light line mark here. X. And now you are called x. X is from here. Then see a plus go that side. You know. At that point we need bending moment here. So next right. What all I tell? See, first calculate bending moment at x for real beam, not this beam, real beam. 18 into x. It is plus 18 into x. Go back and mark there. 18x. Then therefore intensity of load for conjugate beam at x, you should write, is equal to 18x by EI. Go back and mark that also. If that is 18x, this ordinate will be 18x by EI. Remember, the point x is here. Without disturbing, x is from here. Okay, start. Now, consider theta x equal to 0. Now, theta x clockwise in real beam equal to shearing force at x in conjugate beam, left up positive, right down positive, equal to slope here is shear force here. Look right side. Right up is negative, equal to minus 165 by EI. I will put black color. Only x I will put red color. Equal to minus 165 by EI. Only shear force. Plus this much load is half into x into plus ಇದೆಲ್ಲಾಗೋಯ್ತಲ್ಲ ಇದೆಲ್ಲಾಗೋಯ್ತು ಅದೊಂದು ಬಾಕಿ ಇದೆ ಅಷ್ಟೇ ಪ್ಲಸ್ ಹಾಫ್ ಇಂಟು x into what? 18 times x. X is red, other is black. 18x by EI. This is the shear force. Now, you know that theta x is equal to 0. Therefore, equate to 0, tell correctly the value of x fast. Tell correctly value of x in meter. How? EI cancels. 165 goes that side. 165 into 2 divided by 18 will give x square. Take root. Give me 4 decimal answer. First, x value. Give me 4.2817 meter. Saku. 4.2817 meter. 4.2817 meter. Therefore, those who want, write a statement here. What statement? Therefore, for this beam, maximum deflection will take place, 5 meter though, at a distance of 4.2817 meter from B. From B to center is 4, slightly after center, but before the load. If you want, write it. That I write last. Lastly, to get y maximum. To get y maximum. See, you know that y maximum is y at the point x. Okay. Now calculate y at the to get that ink spreading. Okay, to get. To get y at the point x down in real beam equal to bending moment at x in conjugate beam sagging positive equal to find the deflection here is bending moment here. Okay, look this side. Plus 165 by EI into x. Substitute later. Plus 165 by EI into x. Then minus moment of this much load about this point. Half into x into 18x by EI. Half into x, wherever x red color. X into what? 18 times x divided by EI is the total load into moment about this point. For this triangle, CG will be here 1/3 of x. Very sorry, I will not explain why 1/3. There's a limit for everything. Or equal to, now see, now substitute for x. Substituting for x, you get equal to 165 by EI into x is 4.2817 minus, see, numerator is 18, denominator is 3 into 2 is 6, 18 by 6 by EI into x into x into x is x cube, that is 4.2817 cube. Correctly tell the answer. Something plus will come, plus something divided by EI. How much number? Y max number. 470.9918 is 992. 470.992. 992 positive. 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 This is Yx. This itself is Y maximum. Lastly, okay, I also got same answer here. Lastly, presentation. How? See, I'll sit and write. Therefore, maximum deflection for the beam equal to 470.992 by EI meter. Down it is, down, where? At 4.2817 meter from right support B is the final answer. See, moment area in one full class we can complete only theta A, theta B and theta C and YC. Y max you could not do it. Moment area. Conjugate, we completed the question. Still time is 8:15. See there? Still half the class. There to complete, we took 2 classes. Why? So tell me which better? For such questions, which is better? Moment area or conjugate? Symmetry means both are same. So when symmetry is not there, tell me ideal method. Moment area or conjugate? When symmetry is not there, which is better? If symmetry is not there, conjugate better. Okay, now first question is completely clear. I will start second question and go outside. You should not outside from away from here. You should correctly solve and tell, got all these values. This I will do. This I will do because my location is changing. I will do it. Okay, start. Second question. Okay. These all you should not do it. Okay, I will rub and write. Why unnecessary? This is difficult. But remember, no explanation. Second question, no explanation. I will start second question now. Correctly solve. Today both should be over. Okay, now this all I am not removing because why? You can refer here. Question number 2 continued. First what you have to do? Write the beam, find support reaction. Then draw the beam neatly here. real beam. Get the real beam. This is real beam. There's a reaction here. There's a reaction here. Now you can do one thing. You can do rough calculation. After the class is over, make fair copy. Don't make fair copy now. Now rough calculation. Why? To continue. Okay, now. Load is somewhere here. It is little this side further. Okay, okay. The line tappoitu. That's no problem. It is not a big issue. See, load is here. It is 120 kilonewton is the load. So this is the point C. Remember, this distance is 6 meter. This distance is 4 meter. This is your VB. This is your VA. You already got the answer. VA equal to 48 kilonewton. VB equal to 72 kilonewton. Okay, now I will keep quiet. I will silently finish and take rest. You should correctly complete. 288. Correct, 288. I think 288 is correct, I think. 48 into 6. Ayo. Correct, 288. Now that's all. Plus. Y max I will do it. Don't worry. Plus. Then. Same way, write this is the BMD for real beam, sagging positive, all are kN meter. You only show the calculation. Then below, draw BM by EI diagram. 288 by EI. Then down. Below, this time no blue color, only black color. Why? It is partial solution. AB, this is the conjugate beam. This reaction is called VB dash. This reaction is called VA dash. From here to here is 6 meter. This is 4 meter. This is AB. This is your C. Okay, now enjoy the calculation, get VB dash, enjoy the calculation, get VA dash, and correctly complete all this value. I will write new value using new value for this question. I will write here new values. Use here. I will change over to new values here. Old value cancelled. Same way do it. I will put the new value this side using any color. I will use red color. Why? To show that it is not, okay, blue color. With blue color, I will write the new values. So that you should do systematically. Okay, start. You can start. Hi. What is this? 768 by EI anti-clockwise. 672 by EI clockwise. 192 by EI anti-clockwise. By negative will come. Anti-clockwise. 2304 by EI meter down. Your VB dash will come 768 by EI. Your VA dash will come 672 by EI. I'll give you 5 minutes time. In the 5 minutes time, or maybe 2-3 minutes extra, can you correctly complete this much? Tell me. I'll give 5-6 minutes for you. If I give 5-6 minutes for you, can you correctly complete this much? Y max I will do it. In 5-6 minutes given for you. Can you correctly complete up to here? Tell me. I take a rest. First of all, I need not tell anything. This much also I should not tell. Can you complete? As soon as you complete and get all the values, your type got all the values. Okay. As you finish, you should type there, got all the values. All the values should come for you. Then I will take over and finish the red part. Then I will finish the red part, because red part, some small changes are there. Red part I will do it. Okay. What try? There is nothing here. When I got so fast answer, you can be slightly slow. Even you are also, nowadays, you also understood everything. Therefore, little maybe, not my speed, little lesser speed. Okay, start. Don't waste time. As soon as I see you would comment, got all the values, I will continue. Red color. Okay. I get some rest for that one. I'll finish the question now. You typed that, got all the answers. See, actually, you did not give any rest to me. When the moment I went there, I sat for some time. Usually what I do is I go to some news item, anything, any news is there today. By the time opened that news channel, your message came there. Got everything. I'm happy. I will see later, no problem. See, that should be the response. You should tell answer came very fast. That shows dedication. All the values came. So, now see. Same statement, calculation of maximum deflection for this question. See, this sketch will change over now. I'll tell you now. See what happens. I use a paper only. Wait. Now, second question. See, here, the beam is like this. See, the beam is like this. Load is somewhere here. So, natural bending will be like this. Ayo. Hand slipped there. Natural bending. So, this is A, this is B, this is T. Tell me, Y max will take place from between or to the left upload point or right upload point. Now, Y max will take place to left upload point or right upload point. Y max will take place to which side upload point? Left upload point or right upload point? Answer. Y max to which side? Why no answer? To left upload point or right upload point? To left upload point. Right here. Y max will be between not B and C. Now it will be between A and C. Okay, that is somewhere here. Somewhere here. Yx equal to Y maximum. Let it be X. Now X should be from A. X should be from A. Why? Ya, I told just earlier, Ya. Because here, if you take from B, when you take here, that side, triangle trapezium. This side, triangle. To locate that one, same story, no change. Now, one by one. First, what do you require? First, you require slope theta x 0, Bm at x for real beam. See here. Come back here. Mark that point somewhere here without disturbing other points. This is x from here. If that is x, this value you require. You should write. I am not writing. Bm equal to how much? Plus 48 into x. So this will become 48x by EI. Enter that one here. This is 48x. This is same corresponding ordinate here is 48x by EI. Now, this much triangle you have to see. Start. Slope x real beam. Shear force at x in conjugate beam. Look left side now. Look left side. Plus 672 by EI. Plus 672 by EI minus this much load. Half into x into 48x by EI is the total load. Equate this to 0 and tell me the x value. Okay, I have not done the calculation. I will do some other way. I won't do this way. I will do some other way. Because I don't want this method. Where is the slope at A? 672. Tell me, over. My work is over. Tell the answer, x value, 5.2915. Yes, I also got same thing. 5.2915 meter. Those who want write a statement, what? So this question, Y max will be between A and C at 5.2915 means after center but before the load. Now, same calculation. See, deflection here is bending moment here. it is, this will change. Why? You are looking other side. This will change. Bending moment there is plus 672 by EI into X minus half into X into 48X by EI. 48X by EI is the total load into 1 by 3 of X. If you simplify, substitute for X, it will become what? It will become 672 by EI into X is 5.2915 minus, this is 48 divided by, this is 6 EI into X into X into X is X cube, that is 5.2915 cube. Tell the answer in terms of EI. Tell the answer in terms of EI. Over question. Tell that answer in terms of EI. 2370.593. Oh, I also got same answer. 2370.593 by EI. That is Y. That is therefore that is the YX. That YX itself is Y maximum. Therefore, Y max equal to 2370.593 by EI at what distance? At distance 5.2915 meter from A. Both the, see, moment area method, if you remember, we struggled 2 classes. But today, even after finishing, see, just 835. That is, both the question in one class, that too not full one class, a part of the class. That clearly shows conjugate beam method, especially for simply support beam, when symmetry is not there, is very useful. That tangent, imagining elastic curve, what is the deflection of C with respect to A, nothing like that. Slope you want, shear force. Deflection you want, bending moment. Is crystal clear? Tell me. Crystal clear or not? Is it crystal clear? This is crystal clear means I will do one thing now. See, the couple question where you are not asked. The question of couple, I applied a couple on the left side. I applied sagging couple. If hogging couple is applied, BM will come negative, load is down, upward will become. And if double couple is applied, that question, because you know solution, see, if double couple is applied, instead of triangle, rectangle will come. Work is simplified. To save the time, shall I take those 2 classes recorded and upload? To save the time, I will put title, deflection for simply support beam by conjugate beam method, subjected to couple either at one of the end or at both ends. To save time, shall I upload? Because here if I tell means, very briefly I can't tell. There advantage is there. I will explain everything, maybe in half an hour class. Okay, now do one thing. This question very important. You do one thing. You solve the question earlier given by moment area method. And also, to get complete control, you consider 2 more questions, homework. I will give the question without any hint. Okay, see. This is practice questions. Practice questions. 1. Simply supported beam, any span will do. Okay. Span 12 meter. Loaded by a point load here at say distance is 4 meter. It load 100 meter there. I should take a multiple of 3 and 6. 90 kilonewton. This is one of the homework question. What they want? Okay, here. They want theta A, theta B, theta C, YC and Y maximum. Y maximum red color. Now no red color. Okay, red. Second question. Simply supported beam of span, any span, okay. 5 meters, small question. Load is somewhere here. Load is multiple of 3 is advantage for me to avoid changes. The 36 kilonewton. At only 2 meter from here. See, here Y max will be this side, Y max is this side. A, B, C. Here also, you want theta A, theta B, theta C, YC and Y maximum. Can you correctly solve both the questions? Tell me. I will give answer for you. Can you correctly solve both the questions? If you can solve means, I will give answer and you can practice. Okay. I start. Thirty and 60. Sufficient for me. Theta B is 640 by EI, anti-clockwise. Theta A is 800 by EI, clockwise. Theta C. $320 by EI. 320 by EI, it is clockwise. Deflection at C. $2560 by EI, meter, down. Y max at will be at 6.53 okay, 53197 meter. You can take 532 meter from B, and Y max equal to theta B is to 640. $2786.974 by EI. This question. That question. 14.4. 14.4 minus 36 is 21.6. Okay. $50.4 by EI, clockwise. $57.6 by EI, theta B, by EI, anti-clockwise. Theta C. $14.4 by EI, radian not required, anti-clockwise. Deflection. $86.4 by EI is the deflection under load. Y max will be at theta 50.4. 2.64575 meter from A, and your Y max answer is low reaction 14.4. $88.8973 by EI is Y maximum. Okay. I gave both the questions, every answer given. Can you systematically solve both the question and get complete grip on conjugate beam method? Tell me. Systematically solve both the question, and today our 2 class questions. Solve these 2 questions. See, this way only you get perfection. Then moment area method, I solved some questions. I don't know the question because I first thought I will solve same. Then I have to go to YouTube, I have to search the class there, and then I have to open it. I thought, why, when I can give the answer, why should I unnecessarily do same question? Therefore, I do same question only in indeterminate structures. When I take SD, MD and Kani's method, there what question I solve by SD, same by MD, same by Kani, not 1 micromillimeter difference will come. That is a prestige question for me, because there I never take chances. Identical question, so that not a single question different answer will come. These are all nothing. So I thought, instead of struggling all this, set a new question only. Okay, solve. Now still 20, 50, 12 minutes time is still there. I will take rest. So that couple question I will upload. So next class, next Tuesday, I will go for cantilevers. So cantilever, what happens is, some principles are there. So next class will be conjugate beam method for cantilever. And later, I will solve one question for conjugate beam method for overhanging beam. Moment area you can solve, but complications, it is confusion, nobody will solve. So conjugate beam method can be very effectively used for overhanging beam also. That I will take one question. Cantilever, since we covered all the case in moment area, not too much work. Some key questions you can solve. Then I will tell you all the questions we solved by what? Moment area method, solved by conjugate beam method, check the answer. 9 standard question comes in SDMD Kani. In SDMD Kani's method, that 9 standard question, it will perfectly tally. See, now for that FEM class, today or tomorrow, I am recording that 9 standard questions for FEM. But when the time for answer comes, I will not do by FEM. I will apply my own tricks. That 9 question will make complete grip on what? SDMD and Kani's method. All boundary conditions. How to account for it. Okay. Thank you. Next Tuesday, that appointment I told is not decided. One fine day I have to attend that. I have got doctor's appointment. I do not know when. Whenever is that day, I will inform you earlier. It was supposed to be 2 days earlier. It was cancelled, so I took the class. So when it was there, same day, I will not send a link for you. I will send a message. Else, link will come for you. Meanwhile, study all the questions and get a complete grip. See, these things are, once you understand and get the grip, you become unbeatable. You also try to solve and get the answer the way I give the answer. If you try, it is possible. That is not impossible. Only thing is, you have to mix the concept. Okay. Time being, don't try. Okay. Thank you. Time being, don't try.